Hello everyone, I'm Jacob Kauf and I'm the nerd on the street, and today I'm giving you an introduction to Ansible. Okay everyone, so Ansible is an IT automation platform that was first released in 2013 and was acquired by Red Hat in 2015. Today, Ansible is a major part of Red Hat's products lineup, but until just about a month ago, I had never used Ansible. However, as of this week, I am a Red Hat certified engineer, and a lot of the objectives on the exam for that certification have to do with Ansible, so I've gotten quite a bit of hands-on experience with it over the last few weeks as I was studying for that exam. Today, I'd like to take a few minutes to explain what Ansible is and show you some real-world examples of how you can use it. We're not going to be covering things as in-depth as you would need to pass the Red Hat certified engineer exam, for instance, but this video is intended for people who, like me, just sort of ignored Ansible for a while. Maybe you know that it exists, you've heard the name, but you're not sure what it is or why people use it. Like I said, Ansible is an automation platform, and at its core, it's really just a way that you can control lots of machines at once. So if you've got a fleet of a dozen servers or hundreds or even thousands of servers, you can manage all of those servers from a single control node. One of the key features of Ansible is that it doesn't require any client-side software running on those fleets of servers that you're controlling. You can actually control Windows devices, various Cisco products, lots of different types of equipment with Ansible, but when it comes to controlling Linux servers, Ansible does all of its work over SSH, and it uses common system tools to do what you tell it to do. So the only requirement before you start using Ansible is that your control node has SSH access to all of the machines you want to control. I would say that everything you can do with Ansible you could theoretically just do with the bash script, but the advantage to using Ansible is that you're using a program designed to apply a consistent configuration to a large group of servers. It's designed to be idempotent, so you specify the state you want the servers to end up in, and then you can run Ansible with your set of instructions called plays against your servers as many times as you want. And running those instructions more than once isn't going to mess anything up, because the instructions aren't just specifying what Ansible is going to do, they're specifying the end result you want that server to end up in. So if the server is already in that state, nothing's going to be changed. Even though Ansible is a Red Hat product, it does work with other Linux distributions as well. So today what I'm going to do is set up 5 servers. I'm going to have an Ansible control node that's going to be running CentOS 8, and I'm going to have 4 servers that are managed by Ansible. 2 of those servers are going to be running CentOS 8, and 2 of them are going to be running Debian 10, just to demonstrate that you can control many different servers with different operating systems on them using the same Ansible control node. Like I said, Ansible instructions are written in plays. The plays contain different tasks that Ansible is going to perform, and you can make a playbook that contains multiple different plays that Ansible is going to run through. And all of the configuration is stored in a format called YAML. It's a little bit particular about usage of white space in your files, but it's quite human readable, especially once you've started working with it for a little while. My intention with this video is really to demystify Ansible for the new user and show you what it's capable of from a server administrator's perspective. So without further ado, let's cut to the desktop and get started. Alright guys, and here we are on the desktop. I'm going to go ahead and create our 5 servers first, and then we'll talk about the setup we need to do before we can start using Ansible. So our first server is going to be a CentOS 8 server. I'm going to use the cheapest option available here on DigitalOcean, and I'm using DigitalOcean for my example just because I've got a lot of credit built up on here, but of course you can use Ansible to manage physical servers, virtual machines, VPSs, any type of Linux server. I'm going to add my SSH key so I can log into the server right away without needing a root password generated, and this server I'm going to call Ansible controller. So we'll create that. While that's provisioning, we'll create 2 of our managed nodes, and these are going to be the 2 CentOS managed nodes, so also running CentOS 8.3. They're also going to have my SSH key installed just so I can get in to do the initial setup, and the host names will be CentOS 1 and 2. We'll spin those up. And finally, we will create 2 Debian servers to be our other 2 managed nodes. Those will be running Debian 10, and these are going to be called Debian 1 and 2. All right, so it looks like our Ansible controller has an IP address already. Now, before I SSH into that, I am just going to show you what we need to do before we can start using Ansible. There aren't very many requirements. Like I said, our managed nodes will not need any software installed. However, we do need to set up some permissions so the Ansible controller will be able to control all of our managed nodes. So for one thing, we're going to start by making an Ansible user on every node, both the controller and all of our managed servers. Now, you don't need this user to be called Ansible, and you don't even necessarily need to have a dedicated Ansible user. You can use Ansible as the root user, and you can just run everything as root on all of your servers. Obviously, that's not a great security practice, and the advantage to having either an Ansible user or an automation user or some sort of dedicated user for your Ansible automation platform is that when you're looking at logs, if your Ansible user performs an action and that action is logged, you'll be able to very easily identify, okay, that action was being done from the Ansible controller node. So if you want to know why it happened, you can go back and look at what you have set up on the Ansible controller node. As opposed to if you were running Ansible as root, you wouldn't really know in a log file whether an action was performed by Ansible or by a system administrator doing something manually, either using sudo or while logged in as root. Now, just creating this dedicated user isn't going to really secure things in and of itself. There are identity and access management capabilities built into Ansible Tower and other Red Hat products that you can use along with Ansible to control who's running tasks as this Ansible user, but we're not going to get into that today. Now, on all of our managed nodes, Ansible needs to be able to do its job, and a lot of those things are going to require root access. So Ansible needs to be a sudoer, and it needs to be able to use sudo without entering in a password on every managed node. Your automation system won't be very automatic if you have to enter in a password for every single one of your servers every time you try and run an automated task. The idea here is that you click one button or type one command and it's going to do a lot of things for you automatically. And so to be able to do that, the Ansible program and the user that it's using needs to be able to perform root operations. Now, Ansible does not just support sudo, it does support do as, it supports regular old su, and a few other options. We're going to use sudo since it's a default option that's available on both Red Hat and Debian-based systems. Finally, the Ansible user, once again, it needs to be able to SSH from the control node to manage nodes without a password, and SSH is how Ansible is actually going to connect when you run tasks. And then once we've got all of that set up, we can install the Ansible package on our controller node, and then we can finally get started using Ansible. A lot of this stuff that's done on all the managed nodes, I'm about to do it manually. Really, if you were doing this at scale, you would want this to be built into your imaging process or something like that. But I'm going to open up a terminal here, and I'm going to SSH into our Ansible controller node. And I am logged in here. So we are going to start by adding our Ansible user add -m Ansible. The -m is just going to create a home directory for us. And now I'm going to log in as that Ansible user, and to do this at the terminal here, I'm going to just use su-ansible. That's going to log me in as Ansible, and if I say who am I, you can see I'm logged in as the Ansible user. If I print my working directory, I'm in the Ansible user's home directory, and I'm going to go ahead and generate an SSH public-private key pair with SSH-keygen. And I'm not going to change any settings. I'm going to leave this at the default location. And most importantly, I'm going to not enter a passphrase. If you do set up a passphrase, you can set Ansible up to have that saved. That way, if somebody steals your key from the Ansible controller node, they won't just be able to use it to connect to all your servers. That's an option that's available, but just for simplicity, we're creating it without a password for now. So we've got our Ansible user on the controller node, and I'm going to go ahead and cat out our .sh/id-rsa.pub. This is our public key that needs to be installed on all of our managed nodes. So I'll open up a new terminal, and in this one, I'm going to SSH into our first CentOS server. So I'll SSH root at that CentOS server, and we'll just get connected here. So once again, I need to add a user add -m Ansible. Now, in order to give that Ansible user sudo privileges, you might think that we just need to add it to the wheel group. However, that's not what we're going to do today, and let me show you why. If I run usermod-a wheel Ansible, that's going to add the Ansible user to the wheel group as a supplementary group. The capital G means we're not reassigning our primary group, we're just adding this additional one to the Ansible user. And now if I log in as Ansible, if I do su-ansible, I'm logged in, and if I run sudo test, I'm going to get this prompt here. This is asking me for my password. Now, there are a couple problems with this. For one thing, we have not set a password for the Ansible user, so I don't have a password to enter. For another thing, like I said before, we don't want our Ansible administrator to have to sit there entering in passwords manually for every single server that Ansible is going and touching when we're running a playbook. Now, the reason sudo is set up to ask for a password separately from just logging in the first place is so that if you log into a server and then you walk away from the server while you're still logged in, somebody else who sits down a few minutes later won't be able to just run any old administrative command with your user. However, in this case, this is an automation user. We're just going to go ahead and say that nobody's logging into our endpoints with this user manually, at least after the setup's done. It would be very hard for them to do so since we're not setting a password and password authentication isn't even enabled on this server. Now, it is possible to configure Ansible to provide these passwords manually, but that's just outside the scope of this video, so we want to be able to run sudo commands without this password prompt. So I'll hit Control-C to get out of this password prompt. I will exit back out to my root user, and we're going to run vsudo to edit our sudoers file. Now I'm going to type in /wheel to search for wheel, and this is going to bring us down to the line that allows the wheel group to run all commands with a password prompt by default. Now, if I were to comment this line out and then uncomment this line down here, this lower line would allow any user in the wheel group to run any command as root without entering a password. That's not actually what I want to do. Maybe there are other sudoers on this system, and I want sudo to behave as expected for those users. I want them to be prompted for a password. It's just our Ansible user that I want to exclude from this. So I'm going to come down to this line. I'm going to hit YY to copy the line, and then P to paste it in. And then I'll hit I to edit this line here. And we are going to replace the % wheel, which is signifying the wheel group, with just Ansible. And if we specify a word without a % at the beginning, this is specifying the actual user. So we're saying the Ansible user in particular is allowed to run on any system, any command that it wants to, without entering a password. So I'll hit escape, right quit, enter. And now if I log back in as Ansible, I can run sudo test, and I'm not prompted for a password, which is exactly what we want. The last thing I need to do on this node here is allow SSH access using this SSH key from our controller. So I'm going to copy the public key over here. If I do an ls here on our directory, we can see we don't currently have a .ssh file over here. Now, if you wanted to, you could set a password for your Ansible user. Since we're logged in as Ansible, we could just run password. Then I'd have to go and enable password-based authentication on this server since it's disabled by default from DigitalOcean's imaging process. Then we could come back over to our controller node and we can run SSH copy ID and then type in the IP address of our managed node over here. That would prompt us for the password, and then once it logs in with the password, it would automatically copy this public key over to the managed node. That sounds like a lot of work because it is. We don't need to do that. We're not going to need password authentication once we set up key-based authentication, so I'm just going to do it manually, and it will actually be quicker, at least if I hadn't explained it. I'm going to run makedirectory.ssh, and then I'm going to v into .ssh authorized _keys. And in here, I'm going to go into insert mode. I'll paste this. I've got a video about using Vim. It's actually about text editing on Linux in general that you can go and check out if you're not familiar with Vim or V. But I've saved that public key in my authorized keys file. And now if I come back over to my controller, I can SSH into Ansible at 104.248.8.122. And I should not be asked for a password when I do this. It's asking me to verify, since this is the first time I've connected, that this fingerprint is correct. I'll say yes. And I've got permission denied. Okay. Let's take a look at our permissions because I'm guessing this is a problem with permissions. If we take a look at our .ssh directory, this would be 775, which is not what we want. And this would be 664, which is also not what we want. So SSHD is ignoring this file right now. So when we're doing this manually and we're creating our directory and our authorized keys file manually, we need to remember to set our permissions. And to do that, I'll run chmod 700 on our .ssh directory. This is going to set it so that our user, the owner of this directory, can read, write, and execute, but nobody else can go into that directory, nobody else can traverse it, and nobody else can read or write to or from it. So I'll run that. We'll run chmod 600 on our .ssh authorized keys file. And this is the same thing, except we don't need our user to be able to execute authorized keys. This is not a script, it's just a text file. So 600 is going to give the user read and write permissions, and everybody else, once again, should not be able to look in here and see who's allowed to connect as this user. I also have a video about Linux permissions definitions that you can go and check out if you want to learn more about how those numbers work. But now if I come back over here and try that again, I am able to log in to our manage node from the controller, and I was not prompted for a password. So that's set up exactly how we wanted to set it up. I can run sudo test again, and I'm not asked for a password, so that's perfect. Now, one last piece of this puzzle, I do want to be able to SSH in using a host name rather than the IP address. So that's going to be CentOS1 in this case. You can see that's not a fully qualified domain name, and I don't have any DNS records for this IP address. So that's not going to work by default. So in order to do that, my Ansible user, for demonstration purposes, I didn't add it to the sudoers group over on this controller because we're not going to be managing our controller with Ansible. You can if you want to, I'm just not in this example. But I am going to exit back out to my root user so that I can edit my etc hosts file. And in here, there's a scary comment at the top that says this file is not persistent. That will not be here on a default installation of CentOS. This is an artifact of DigitalOcean's imaging process, and it is incorrect. This file is persistent, despite the comment. So we are going to add in our IP address, followed by the host name of our managed node. I'll write and quit that. So now I can ping CentOS1, and you can see that it's resolving to that IP address. If I try and SSH in from my root user, it's not going to work. If I SSH into CentOS1, it's going to fail because we don't have any SSH key from our root user configured on the managed node. But if I log back into the Ansible user, now I can SSH into CentOS1 by name. It's going to ask me to confirm the fingerprint again since we're connecting using a host name for the first time. But it is going to let me in. If I clear out of that, I can do it one more time. You can see I'm logged in. This is the controller node. I'm going to SSH into CentOS1, and it's just going to let me write into CentOS1. So I need to do that on all of these servers. I'm going to cat out my SSH ID rsa.pub one more time. I will go ahead and get our setup document out of the way here, and I'm going to grab the IP address for our second CentOS node. And I might just speed up the video here while I perform those exact same steps on this second managed node running CentOS. All right, and unless I forgot anything, I should now be able to SSH into CentOS2. And after confirming the fingerprint, I can get in there and I can run sudo test. I'm not prompted for a password. Perfect. So now we just need to do it 2 more times for our 2 Debian servers. We'll exit back out over here. Now in our Debian system, you can see here that we don't have as many examples in this file. The syntax will still be the same, we just don't have the example there. So I'll add in Ansible, all equals all, no password, all. Now you might notice that we are currently not in Nano. Hitting Control X doesn't really do anything to get us out of this document. We're also not in V. Hitting Escape doesn't do anything, and the colon does not get me any sort of command prompt. Fun fact, this vsudo command, the top of the sudoers file says this file must be edited with the vsudo command. That's actually a lie. You can open up etc sudoers in Nano or Vim or any editor that you want to, as long as you're doing it with root privileges. The reason we use the vsudo command is because if you make a typo or if you mess up your syntax, vsudo will warn you. It won't let you save invalid configuration. And so that prevents a system administrator from locking themselves out of the system by destroying their ability to use sudo commands. But I do often just edit this with Nano directly instead of going through vsudo, just because I never really take the time to set up my editor environment variable. And so it just throws you into whatever editor is set up by default. We're currently in an editor called Joe, and it's a recursive acronym for Joe's own editor. I've never been in this editor before. I don't think I've ever used it once. But to get out of here, we're going to hit Control K and then Control Q, and it's going to ask us if we want to save this modification to the file. We'll hit Y, and it will save that and exit out. So now that we've done that, I can go ahead and log in as our Ansible user. It looks like we're in sh here instead of bash. So another way that Debian is different from CentOS is when you create a new user without specifying what shell you want, it's going to give them the sh shell by default instead of bash. That's not a problem for us. If we do print working directory, you can see we are in home Ansible. If we do an ls alh, we've got bash files here. We just aren't logged into bash. I am going to just make a directory .sh, and we'll do the same thing we did before, nano.sh, authorized keys, copy and paste that key into here, chmod 700 on .ssh, chmod 600 on .ssh authorized keys. We don't have tab completion in sh, which is annoying, but I think we've done everything we need to do. If we come back over here, let's add this to our etc hosts file, 134.209.38.107. That is Debian 1. And so we'll log in as Ansible. We will SSH into Debian 1. And we are logged in. We've got an sh prompt, and we can do sudo test, and we're not prompted for a password. Nice. I am just going to go ahead and set our shell. That was not intentional, having it default to sh. I don't think it would mess anything up, but to change a user's shell, we can run usermod -s for shell bin bash Ansible. And now if we SSH in there again, we should get bash, which we do, which is good. We're going to be using the shell module with Ansible later. That's the only reason why I want to make sure we have the same shell on all these machines, just so we have consistent output. So now we will set up our final server here, our final managed node, which is going to be Debian 2. So we're going to run user add -m Ansible. I'm going to specify -s for the shell. We'll make that bin bash so that we don't have to worry about that again. This time when we run vsudo, I'm going to append editor equals nano to the front of the command. That will set our editor environment variable to nano for this particular command, so that sudo puts us into nano instead of that weird Joe editor that it used before. We'll enter in Ansible, all equals all, no password, all. We'll save that. We'll log in as Ansible, authorized keys. All right, and we will log in as Ansible on our controller again, SSH into Debian 2, and we'll run sudo test, and we're not prompted for a password. All right, I am currently 43 minutes into our recording for this Ansible video, and we are now ready, almost ready, to start using Ansible. We do, of course, need to install Ansible. There is an Ansible command, and if we just run Ansible, you can see it's not found because we haven't installed it yet. Now, ironically enough, Ansible is in the default repositories for Debian, so if your controller node is a Debian machine, you can run sudo apt install Ansible. However, here on CentOS, Ansible is not in the default repositories. It's not in the default repositories for Red Hat either. If you're running a Red Hat system, you can get Ansible through Subscription Manager. Since we're here on CentOS and I do not have a subscription to Red Hat Enterprise Linux, we are going to get Ansible from the EPEL repository. I'll open my web browser back up. This is a page on the Fedora wiki about EPEL. It stands for Extra Packages for Enterprise Linux, and there's a command right here that we can run on CentOS 8. That is going to download a package and install it. That package is going to add the EPEL repository to our system. And I need to do that with sudo, which for my demonstration purposes here, my Ansible user on the controller node does not have root privileges. So I'll just run it here. Logged in as root. Okay, and we will run dnf install -y. I'm going to install Ansible. I'm also going to install Nano at this point on our controller here. CentOS does not have Nano installed by default, and that's the text editor that I'm most comfortable with. So that's what I'd like to use while I'm building these Ansible configuration files with you guys. So I'll run this. And you can see it's pulling in Ansible. It's also pulling in some Python dependencies. Ansible modules are written in Python. So if you ever find yourself needing to write a custom Ansible module, which is very unlikely, but if you ever want to do that, it's done in Python. That's how you would do it. The reason I say it's unlikely is because there are a ton of Ansible modules out there already that can do most of the things that you could think of automating. And whatever you can't do with existing modules, you can probably do with the shell command without having to write an Ansible module just for what you're trying to do. But in any case, that is finished running. So now that that's been installed, I can access my Ansible user again. And as the Ansible user, I can just run the Ansible command, and we're going to get a little bit of usage information. We're not going to go through all of this. I am going to bring your attention to the default Ansible configuration files, which are located at etc Ansible. If we take a look inside of there, you can see we've got etc Ansible, Ansible CFG. This is the default Ansible configuration file. And then we've got our default Ansible inventory file here at etc Ansible hosts. Now, an Ansible inventory file is telling Ansible what hosts are available to perform actions against. It's not necessarily saying what you're going to perform each action against. You specify that with the actions, but this inventory file is going to be a registry of hosts that are available to be managed with Ansible. We've also got a roles directory, and roles are a more modular way to specify tasks that you're performing, as opposed to a regular old Ansible playbook, which is what we're working with in this video. I'll probably make a follow-up video about roles, but for now, let's take a look inside of this default Ansible configuration file just to see what's in there. Now remember, our Ansible user on our controller node here does not have root privileges, so we won't be able to edit this file, but we can take a look inside of it because all these commented values are the default values. So the default inventory file, like I said, is etc Ansible hosts. Down here you can see the default sudo user that Ansible will attempt to escalate privileges to on our managed nodes is root, and by default it will ask us for the password for sudo and just for SSHing into the machine if we don't have password lists set up for those things. Of course, we did it properly, so we're not going to be prompted for a password when we run Ansible against our managed nodes. Down here we've got an option for when we're going to gather facts. Now, by default, whenever you perform an action against an Ansible node, the first time that Ansible touches that node in your playbook, it's going to gather a bunch of information about the system, and that information is going to be stored in variables that you can then reference later on in your playbook. So by default, Ansible is going to gather facts by default, but you can turn that behavior off if you want your playbook to run a little bit quicker and you don't need that information to be gathered. If we keep scrolling down here, we can see our default path for Ansible roles can also be changed. Here we've got an option for remote user that's pretty important. So you can see it says user bin Ansible will use the current user as default. So if you just use the Ansible command to run a one-off task, it's going to use the same user that you're currently logged in as. It's going to try and log in with that username on your remote servers. However, when you actually run an Ansible playbook, which uses the Ansible playbook command, it's going to use this remote user that's configured, unless you set a different user in your playbook. That means it's going to try and SSH in with this user, which isn't going to work. Since we set up our SSH key using the Ansible user on our remote nodes and not using the root user. We've got other things that we can configure here, for instance, where we're logging to. A lot farther down here, we've got a section for privilege escalation. Like I mentioned earlier, this is where you can change the method that it uses to escalate privileges if you're not using sudo on your systems. And you can really read through here. There are way too many options to go through in a video, one by one. However, we need to change some of these values, and we don't have write access to that file because it's owned by root. We're logged in as Ansible, so not root, and other people do not have write access to this ansible.cfg file. So how are we going to configure Ansible if we can't touch that file? Well, we're actually going to do it just in our current directory here. If I do an ls, there are no regular files in my current directory. When you run Ansible, it will actually check your current directory for an ansible.cfg file, and if it finds one, it will use that file instead of the global file. So we're going to copy etc ansible.cfg. We're going to copy it right here to our home directory for the Ansible user, and we're going to nano into it so that we can edit a couple of these settings. For one thing, our inventory file is another thing we're going to want to edit. So for that, we're going to use home Ansible inventory. And the other main option we're going to want to edit is remote_user. Like I pointed out before, we're going to change that to Ansible, since that's the name of the user that is configured with the proper privileges on all of our remote nodes. Next, we need to create our inventory file. If we take a look at our default etc Ansible hosts file, that is going to be in any format. .ini format, which is a configuration format you may be accustomed to if you're used to using Windows. And it uses configuration like this. You put group names inside of square brackets, and then underneath those group names, you list out your servers. You can list either host names or IP addresses, as you can see here. You can list ranges, and you can also, within these hosts files, specify variables for your hosts. There are no examples of that here, but for instance, if we wanted to specify variables for the web servers group, we would specify web servers :vars, and then we put our variables underneath that. Now, any files can get a little bit messy to read, especially when you've got a hierarchy of groups that are inside of other groups and variables inside of your groups, because everything is going to be right at the start of a line. Well, I'm glad that my terminal is helpfully telling me what color blue is when I hover over the color names. That's an interesting new feature in console. When you're configuring using the .ini format, all of your hosts are going to be at the beginning of the line, so there's no indentation, and it's a little bit difficult to read. The other way that you can specify your hosts is using a YAML format. That's what we're going to do. So I'm going to nano into inventory, and I could have made this called inventory.yml or inventory.yaml. I just called it inventory to keep it simple. But we're going to start with all and then a colon. That's going to say this is our all group. And this group is not optional. All of your servers need to be on the all group in Ansible. If I wanted to at this point, I could specify my 4 nodes, and I would do that like this. I would say CentOS1, CentOS2, Debian1, Debian2. And in fact, if I just exit out of that file right now, let's check that things are working so far. So we've got our inventory file and our ansible.cfg. Those are in our current working directory. So if what I said about Ansible using the current directory's ansible.cfg is true, when we run Ansible, it should pick up on this local configuration file, which is telling us that our inventory is this inventory file, and this command that I'm about to run should work. I'm hoping it works. So if we run Ansible, we're going to specify which servers we want to run this task against. So I'll say all. And this is the reason why you need that all group, is because Ansible expects you to be able to specify the all group to use all of your servers. We're going to specify a module that we're running with -im, and the module is going to be ping. And this module does not require any arguments. If it did, we would specify -a and put the arguments inside of quotes. But this is a very simple module. The ping module is just going to go out, ping all of our servers, and it will tell us whether or not we're able to reach all of the servers specified in our inventory. So let's try running this. All right, and that didn't work, and the reason is because I forgot to put these hosts inside of the hosts label inside of our inventory file. You know, this is the 4th time I'm recording this video today. I'm over an hour into the recording. I really don't know if this is going to turn out a useful video at all. But this is what your YAML inventory file should look like. So the YAML format for inventory files is a little bit more complicated. Once again, we wouldn't have had that problem if we had used the any format, but we're going to get into more complicated stuff later on in this video, and that's why I'm using the YAML format, because it will be easier when we're doing the complicated stuff. So we're going to put those inside of hosts. Let's try this one more time. And would you look at that? Okay. As you can see, I ran Ansible all-im ping. I did not have to specify which configuration file we were using or which inventory file we were using, but Ansible knew. It read that configuration file that's in our current directory, which points to the inventory file. And now that we've got that inventory file written properly, we've got our 4 servers, and it went out and pinged all of them. You can see the response pong from all those pings. Now you can see here we're getting some warnings for our Debian hosts, and I've seen similar warnings for CentOS hosts before. It's warning us that our Python interpreter is being automatically discovered, which basically means that if somebody installed a different version of Python on the Debian systems, that could break Ansible if it's a version of Python that Ansible doesn't work with. So to fix that warning, we're just going to come into our ansible.cfg file. We're going to specify an option here under the defaults section, and this option is not present anywhere else. The option is interpreter_Python. I'll copy that. If we search for it, you'll see it's nowhere to be found. We're going to set that to auto_silent, and that is going to disable that warning. So now if we run Ansible all-im ping again, we don't get the warning. And this is what Ansible output typically looks like. For each of our servers, we're going to have whether we succeeded or failed in the operation. Then we're going to have a list of Ansible facts that were discovered. We'll have whether or not anything was changed on the server. So in this case, we're just pinging. That's not going to change anything on the managed nodes. So that's false for all of these. And then we get the output from the module that we ran. For an example of something else that you can run easily against all of your hosts, we'll run the setup module. This is going to print out setup information, and this is going to show you all of the Ansible facts that are actually being discovered. So by default, once again, unless you disable fact gathering, all of these Ansible facts are being collected by default every time you connect to a server, and a lot of it is hardware information. You see the amount of RAM, the disk space. We've got our networking configuration farther up, but some of this stuff that's hardware specific, especially say these servers had spinning hard drives, those hard drives need to spin up before you can see how much free space they have, or what their total size is at least. it might take significant time to gather these facts. And so that's one reason you might want to disable fact gathering by default in your Ansible configuration. We're going to leave it enabled though, because we're going to use some of these variables later. But we now have our Ansible inventory file set up. So let's actually start writing a playbook. Like I said, this Ansible command, this is going to allow you to run a single module. And there are many Ansible modules available. If you go to the Ansible documentation, you can scroll through them all. You can see there are modules for Cisco devices, modules for Checkpoint networking devices. There are Azure modules near the top since it's in alphabetical order. F5 devices, Dell, EMC devices, VMware. I saw Windows in there somewhere. There are just a ton of different modules that are in here. And so no matter what you're trying to automate, it would behoove you to go and search and see if there are modules available for it. Once again, if there aren't, you can probably hack something together with just the command module and the shell module, or you can develop your own modules if you want to. So what are we going to do here with our Ansible setup now that we've got this configured? What kind of stuff can this do for us besides pinging all of our servers and telling us if they're online or not? We're going to start with something fairly simple. We're going to start by gathering log files. So let's say that you're running servers and you want your log files to be periodically pulled into your control node so that you can maybe back them up centrally, put them into some sort of archiving system. For logs, there are better ways to do this with SNMP. But let's say that you want to do it at the file system level. You want to create a file that's going to have journalctl for the current boot, which is going to include a lot of useful information. If I just do a journalctl -b0 and I run that through cat here, I'm logged in as Ansible, so that's not going to come up with anything. If I do it here as my root user, you can see journalctl that includes a lot of information that also shows up in dmessage, and that information from dmessage is going to be prefaced with kernel. But journalctl also includes logging from all of our other services on the system. You can see we've got logging from systemd itself when it's starting services up. Then later on, we've got logging from network manager. That's a service that was running. We had cloud in it when the server was being provisioned. We've got SSHD when we were SSHing in. So a lot of information that can be useful to have for security reasons or just for troubleshooting reasons. Let's say that we want to have that pulled in from all of our servers periodically, and we want to be able to do it with a single command, pull in journalctl from all of our servers. Let's take a look at how we would do that. We're going to do it with something called a playbook, and Ansible, like I said, it kind of goes like this. The way that you execute tasks in Ansible is with modules. But the module itself, it's just a tool that you can use. Typically, it's going to be part of a task. And so the module, I'm going to indent it here to signify that the module is part of a task. The task is going to be part of a play, and a play can contain multiple tasks. A task can only typically contain one module. So I'll go ahead and put another task here just to make that more clear. And then the play is inside of something called a playbook, which is just a text file that is defining all of our plays. And so this is the ultimate hierarchy that you're going to end up with. You've got a playbook file. That playbook is going to contain your plays, one or more of them. And then each play can contain one or more tasks. Each task will contain a single module. The reason why it's broken up into a hierarchy like this, instead of just being able to specify modules directly in your playbook without going through all the play and the task, these layers, is because these different levels of indentation in this list here are different places where you configure different things. For instance, each plays are where you specify which hosts you want to run something against. That's one of the things you can configure at the play level. A task is where you can configure other conditionals, such as I only want to run this task if this host that I'm currently operating on is running XYZ operating system, if it's running Debian. Or you can say, I want to run this task and I want to loop through it and do it several times with different pieces of input information. I want to run the same module multiple times using a list. You can do that with a single task. So we're going to get into more complicated examples. I think really the best way to understand Ansible is just to do it. So we're going to create a playbook here. This playbook is going to be called logs.yml. Playbooks are also specified in the YAML format. You do not have the option of specifying them in any other format, unlike the inventory file where you can use any if you want to instead of YAML. Playbooks have to be in YAML. We're going to come into here. Typically, it's good form to start a YAML file with 3 dashes. It's not technically required if we're not putting anything on top of the 3 dashes. You can put basically environment variable type stuff at the top, but we're not going to get into that. So at the top of our file, we're going to start off by defining a play. And this play is going to have a name. The name is going to be collect logs. So this is a play to collect logs from all of our servers. We're going to specify which hosts we want to perform this against. We're going to perform it against all hosts. We also want to specify what user we're going to do this as, and in particular, whether or not we need to become the root user to perform this action. And that's just going to use an option called become, and we're going to say yes. Now, Ansible uses shorthand since this is such a common option to use because so many of the server administration tasks you're going to be automating will need to run with root access. So they don't call it become root user. They just say become yes. If you see this line, it typically means it's being done as the root user. The only time that would be different is if your ansible.cfg or configuration elsewhere is specifying a different user that become will operate with. But for us, it's going to be root. And then down here, we specify these are going to be the tasks inside of this play. Now notice that I had a single bullet point or a dash at the beginning starting off this play because a playbook is a list of plays. Now the toughest thing when I was learning to write these YAML documents, these playbooks, the toughest thing for me personally was getting a handle on the formatting. When do I have indentations? When do I have bullet points? And when do I not? And really, after you've written a dozen playbooks or so, it starts to become second nature, but it helps to recognize what exactly you're listing out. Anytime you've got a dash, which I think of as a bullet point, you're making a list. And so our playbook is a list of plays. All of this information is part of the same play. It all needs to be indented the same so that the YAML parser knows that it's part of this list item, but it is all a single list item. It's all a single play. That's why we only have a single bullet point at this level of indentation. Now down here, we're starting a new list for tasks because you can have multiple tasks in a play. So this first task is going to be called, we'll give it a name. We're going to call it copy current boots logs to file. Now you might be wondering what this name actually does. It's going to be printed out to the terminal while Ansible is doing this operation. It's also helpful to have in here in your playbook so that when you're editing the file, you know what it's supposed to do. You can have comments in YAML. For instance, I could have just said collect logs with a hash mark at the beginning here, and that's not going to be parsed by YAML at all, so that would work for editing. But once again, if we specify a name parameter, Ansible is typically going to print that out while it's performing the operation, which can be helpful. Now, part of this current task that we're editing is going to be running a module. This first module we're going to use is called shell. And this module is going to run a command in a shell environment. There's also a module you can use called command. It's sort of better practice to use command if you know that you don't need to use the shell module. Shell is going to give you your environment variables and things like that, whereas the command module won't. In this case, we actually do want to use the shell module because we're using shell redirection, which is a feature of the shell that you wouldn't get with the command itself. So the command that we're going to run in a shell is journalctl-b0, just like I showed you before. That's going to collect all of the logs for the current boot. And we are going to redirect that to temp journalctl. So the temp directory, we can usually edit that without being root, or we can create new files in it without being root. The reason we need to become the root user for this play is because journalctl, in order to view those logs, we need to be a privileged user. So that right there is a task. It's extremely simple. We're saying, I want to run this command on every single server in our inventory. We're going to specify another task now. And by the way, once again, there was no bullet point before the module because it was part of the same task that we gave a name to. And you can't have more than one module that's part of the same task anyway, so there's no point in bullet pointing those. The next task is going to have a name compressed log file. And for this one, we're going to use a module called archive. Now, archive is a module that takes more parameters than just a single parameter, so it's going to have parameters specified another indentation level in, so another 2 spaces. This is actually the more standard way to do things. Most modules will look like this, where you're specifying multiple parameters. The shell module is one of the few that only takes a single parameter, and so it's easier to just put it on the same line for that one. So the archive module is going to take some parameters. How do you know what those parameters are? Before I type them in here, obviously when you're using Ansible yourself, you won't have me doing everything for you. So let's say that you know you want to archive something, but you want to know what the parameters are to do that. Well, Ansible comes with a program called Ansible Doc, and that's Ansible-Doc. Ansible-Doc is going to give you documentation on your modules. So if we run Ansible-Doc archive, it's going to give you basically a man page just for this module. It gives you a description of what it does. It gives you all of the options that it can take. And then toward the bottom, it gives you some examples for common functions. Below that, it can even give you return values. These are things that you can then store in variables and use in later plays in your playbook and later tasks in your play. Now, the other place that you can get that information is at docs.ansible.com. If you have a web browser, you're on a computer with a GUI, and it's easier for you, you can just come in here and search archive. And even if you're not sure what the archive module is called, just searching what you want to do, archive a file, the first result here is the page for the archive module. So this will give you the exact same information. It gives you a synopsis of what it does, all the parameters you can pass in, examples, and return values, the exact same stuff. Now, personally, what I use even more than the regular Ansible doc command is Ansible doc-s, and you can put the -s at the end if you want to. It can go at the end here instead of in the middle. But Ansible doc-s is going to give you the short version, and it's just going to give you the options that you can pass in, and it's also going to give you the options that you can pass in the format that you would need to use it in your playbook. You can see we've got an example name here. It's in a little fake bullet point. And then just like we did in our playbook, we've got the archive module specified at the same indentation with no bullet points. And then further indented, they use 4 spaces where we're going to use 2. But further indented, we've got all the different options that we can pass in. And it notes at the beginning of each description which options are required. This is extremely useful when you don't want to have to search through a ton of information. You know what you're trying to do. You just need to know how to spell a certain parameter, or if it's DST or DEST for the destination, for example. If you pipe that through cat, it gets rid of the paginator, and then you can just scroll through. You can see, okay, this is DEST for a destination. It's a nice quick way to find out what your different options for your modules are. So we're going to nano back into logs.yml and continue here. And so I'm going to give the archive module the path to the file that we want to compress or archive, and that's going to be temp journalctl, so the file that we just created up here in our previous task. Next, we're going to give it the destination of where we want to save this archive to. That's going to be temp journalctl.tar.bz2. We're going to use bzip2 compression for the best possible compression, slightly better than gzip. We're going to tell it the format that we want to use. That's going to be bz2, and we need to specify that as a parameter because the archive module, it doesn't know, we could call this file whatever we wanted. We could just call it journalctl.tar, and it could be formatted as bz2. The file name is not a reliable way to determine the actual format, so that's why that's a separate option down here. Next, we are going to specify whether or not to remove the original file. It defaults to no. We're going to say yes, or we're actually going to say true. Personally, I like to say true or false for a lot of these options. The Ansible documentation typically says yes or no. The YAML parser in Ansible knows how to handle it either way. I tend to go with true or false just because it seems more correct, more what I'm used to from programming languages. The last option we're going to pass into the archive module is force archive, and that's going to be set to true. And what this does, if you don't set this, it defaults to false. And by default, if you archive only a single file, it's going to archive the file with bzip2, but it's not going to put it into a tar archive. It's just compressing it. It's not actually archiving it. We're trying to create a tarball. I don't care that it's only one file. I want the tar metadata so that I can extract it with tar and not have to remember whatever weird bzip2 specific command I would need to use to extract it. So we're going to use force archive true to make that happen. And finally, we will specify our third and final task for this play. That task is going to be to copy the log archive to the controller. Right now, this is going to happen on every single node that we're managing. It's going to happen individually on each node. So all 4 of our servers will end up with a file at temp journalctl.tar.bz2. That's great. But of course, we would need to go and access each server individually to actually read it. We want to copy them all to our current server. So to do that, we are going to use the fetch module. Now there's a copy module that only works from the controller to the managed nodes. Fetch is the module you use to go from the managed nodes to your controller. So two separate modules for the two directions. The source is going to be temp journalctl.tar.bz2, which is now the only file left over from this operation because archive is going to remove the original temp journalctl file. The destination, this is going to be the destination on the Ansible controller here. That destination is going to be home, Ansible, logs, and I'm going to make a logs directory in our Ansible home directory in just a moment. And it's going to be journalctl dash, and we need to give each of these different files a different file name. There's going to be 4 files because we have 4 servers in our inventory that we're running this against. If we just specify a single name like journalctl.tar.bz2, it's going to do this. It's going to copy from our first remote server to journalctl.tar.bz2. Then it's going to copy from the second remote server and it's going to overwrite the first one. It'll overwrite with a third file and then it'll go to the fourth server and overwrite that file. And so we're going to end up with only one file from one of our 4 servers if we try to name them all the same thing. The way we're going to get around that is with an Ansible variable, and this is a default variable, so we don't need to define it anywhere. To use a variable in our playbook, I'm going to use 2 curly braces, a space. I'm going to close the curly braces. I'll come inside of here. We're going to keep a space in between the curly braces and the name of the variable, which isn't really required, but it's the proper format to write this in. The variable we're going to use is Ansible_hostname, and that's what it's going to look like. This is what the line is going to look like. So Ansible_hostname is one of those Ansible facts, and you might have noticed that I put this line in quotation marks. The reason I did that is because we're using a variable here. And the rules for this are, I don't actually need quotation marks for this. I could get away with not having these quotes, and that would work in this case. However, if you have an option, let's say that we had a variable that contained the full path of the file that we want to save to. If I tried to do this, log_dest path. If I had a variable called log_dest path that I was defining somewhere else, you can do that in your playbook here. I'll show you how to do that. If I tried to define this here, we would get an error. And the reason is because if a variable starts a line that's supposed to be a string, that variable has to be enclosed in quotation marks. If there is no variable in your line, you don't need quotation marks at all. You don't even need them if your variable is not starting the line. However, I don't like to go with the bare minimum formatting required. I like to give myself a little bit more safety than that. And so I've just gotten in the habit personally of, if I'm using any sort of variable anywhere in the line, I include quotes. That way, if I go and change this line later and this variable ends up at the beginning, I won't have any problems. If you wanted to be super strict with your formatting, you could totally put quotes around every string that you're passing in anywhere, and that would be perfectly fine. Personally, like I said, this is just what I've landed on, is if you're starting with a variable, quotes are required. If you don't have a variable, quotes aren't required. So if I'm using a variable anywhere, I just say, okay, that's the line that I'll draw in the sand, and I'll say, I need quotes, or I want to include quotes just for consistency's sake anytime that I have variables. The last option we're going to specify for our fetch module here is flat true. And by default, if you don't specify this, Ansible would create inside of your destination, it would create a directory with the name of the host. Then it would stick the file inside of that directory. So what I said before about how if you don't specify a host name for your destination for the file, it would just get overwritten, that was a little bit of a lie because flat defaults to false. And so if you ran it, then you would actually get 4 directories with the journalctl inside of each of them. But since we're saying flat is true, I don't want all those directories cluttering up my system. I just want inside of this home Ansible logs directory, I'm specifying this is where I want the files to go. This is what I want it to be called. Flat true is going to basically say the destination name is the destination name for the file, not a directory in which to put the file. All right, so we're going to save this, and let's see if that worked. Ansible Playbook. So this is how we're going to run an Ansible playbook. The command, instead of Ansible, it's Ansible-playbook. We don't need to specify our hosts. Unlike with the regular Ansible command for running one-off tasks, you need to specify hosts there. We don't need to do that when we're running an Ansible playbook because we specify which host to run against in the playbook. We just need to specify which playbook we want to run. And in this case, before I do though, let's go ahead and make a directory logs. So if we do an ls, we can see we've got our logs directory there. Otherwise, we probably would have gotten an error when the fetch module was not able to put that file into a non-existent directory. But we'll go ahead and run ansible-playbook./logs.yml. Take a deep breath. We'll run this. Okay, and we got through it. We did not see any errors, which is good. Let's take a look at what we saw there. So as you can see, we had a play at the top here that said collect logs. And the first thing that we did as part of that play is we said, here, let me cat out my logs.yml. So inside of this play, we said hosts all. And so the first thing we're going to do is gather facts about any hosts that we're touching in this play. Now it's important to know that the facts are not gathered at the beginning of your playbook. They are gathered at the beginning of the play where the server is being interacted with. The reason it's important is because there are variables that are defined when these facts are gathered, and I have had situations where due to the order that my plays were written in, I tried to access a variable, and it didn't exist yet because I didn't touch that server until later on in the playbook. The implications of that might not be entirely clear right now to you, if you don't understand what I'm saying at least. I wanted to mention it explicitly because I've found it to be important. So we've got our play, we're gathering facts, and all of these just say okay because nothing was changed when we gathered those facts. Now down here, you can see when we copy current boots logs to file in that task, all 4 of our servers were changed when we did that. And you can see, by the way, that these are in different orders for these different tasks. By default, Ansible is going to go 1 task at a time, but it's going to connect to up to 5 servers at a time by default. You can change that using the forks option in ansible.cfg or by specifying that as a variable. But yeah, we've got 4 managed nodes where it's going to operate on up to 5 at a time. So these are going to be in different orders because it's just going to report as they come in and respond to the commands. So we copied our current boots logs to file. Obviously, none of these servers had that file before, so it was created successfully. All 4 of the servers, we compressed that log file and that went okay. Once again, no failures. And then finally, we copied the log archive to our controller node, and it says changed on all of these. And so we had 3 things that were changed total, 3 tasks where each of these servers was changed. And we had 4 successful tasks because that first implicit task is to gather facts. If anything goes wrong, you're typically going to see the failed counter increment unless you specified ignore errors, in which case it will say ignored, or if you specified a block with a rescue block, which is basically like a try catch in programming, where you say, try to do this, but if it doesn't work, just move on, but do this instead. If you do that, it will increment the rescued counter. Unreachable is when your server's offline, and skipped is when you operate using a conditional and a server doesn't meet that conditional. But in this case, everything was okay. So if we take a look inside of our logs directory, you can see we now have a log file for each one of those servers. We've got journalctl, CentOS 1, 2, Debian 1, and 2. If I do tar xvjf on logs journalctl, CentOS 1, for instance, that is going to put a journalctl file in our current directory here, which we saw since I specified the verbose option for tar. If I cut that out, you can see the last thing that was reported in journalctl was Ansible connecting to the server to run that playbook. If we go back up to the top, though, you can see that this goes all the way back to our current boot. And in fact, let me remove that journalctl and let me tar xvf. So if I take a look at the top of that CentOS machine's log file, you can see the kernel that we were running was a Red Hat kernel, Red Hat 8.3.1, because we're running CentOS, and it's running kernel 4.18.0-240. So if we come back down to the bottom here and we run tar xvjf logs journalctl Debian 1, and I'm just going to pipe that through head because I only want to see the top of it. Oh, actually, I'm getting ahead of myself. I extracted that file. I'm going to cat that file out and run that through head, which will show us the first 10 lines of output. You can see the kernel for this one says Debian. And so we know that these are actually different files. I'm not pulling any smoke and mirrors stuff here. It went to all 4 of our servers and gathered those logs. So our Debian log is going to have a Debian kernel 4.19.0-10. So that is the very first playbook that we have run. This video is an hour and 47 minutes long already. It's going to be shorter after I edit it down. There are 2 more playbooks that I want to show you, but they get progressively more complicated, and I think it would be a good idea to go ahead and split the video here. I did not intend for this video to get so long, but I think it's good. We're getting into detail. That setup took up a lot of time, I know. So stay tuned for my next Ansible video. If you think it's a little dry and simple so far, like I said, we're going to get into some more complicated stuff. If you have any questions about Ansible, feel free to ask in the comments. I am going to go ahead and finish my second and third playbook that I planned to make, but I can make more Ansible videos after that if anybody has questions that aren't covered in those videos. If this video was helpful or interesting to you, you can go to nerdclub.knots.co and join the Nerd Club for just $3 a month to help me make more tech videos like this one. For now though, I'm Jacob Kaufman, I'm the Nerd on the Street, and I'll see you guys in Ansible Part 2. See ya.